Today we're going to take a look at how you graph a quadratic equation using the graphing calculator. Your graph will turn out to be a parabola, which is a U-shape, and we're going to look at how to use specifically the TI-83 Plus graphing calculator to do this. Now there are some key aspects of a parabola that should be found when you're going to graph one. We will be looking at how to find the vertex, the axis of symmetry, the roots, and the Y-intercept. So we're going to start off with a fairly simple equation. That equation is y equals x squared minus 6x plus 5. We all need to recall that in a quadratic equation that there are three distinct parts. There is the quadratic part, which is the x squared, the linear part, which is negative 6x, and the constant part, which is 5. So the fact that it has an x squared term means that as its highest power means that we will end up getting a parabola as an answer. So let's transition here to the calculator for a moment. Okay, TI-83 Plus graphing calculator. As when we do graphing on any type of graph on the graphing calculator, if we're not using the statistics mode, do make sure that you go into your stat plots and make sure that your plots are off. You would choose option 4 in this case to make sure that your plots are off. Hit enter, just to make sure that there's no conflict when you're doing your graphing. Then you'll go into y equals, and we need to enter that equation that we were looking at. We need to use x squared minus 6x plus 5, and make sure that that's entered correctly into your calculator. After you've entered that into your calculator, the first thing that you always want to try is graphing it using the Zoom 6 option. Zoom 6 is your standard graph. Now if that doesn't work, we'll look at a couple of different options, but this first one would do very nicely with Zoom and 6. And we see we have a nice parabola here. We have a vertex point. Even though you can't see it, we have the axis of symmetry, we have a y-intercept, and we have two roots, the places where it crosses the x-axis. So what we need to do is get the calculator to tell us where all those things are. So the first thing that we're going to take a look at is finding the vertex. Okay, the vertex on this calculator can be found by pushing your second button and your trace button, which gives you the calculation. Now on this parabola, we noticed that the U went downwards, so it has a minimum point. So we go down and we choose option 3 for minimum. Okay, we come back on your screen and you've got a blinking cursor here, and that can be followed. You can follow that along the curve by pushing your left and right arrow keys. So if I push this arrow key, you can see that the cursor moves down along the parabola. Now notice that it says left bound. So we want to find out where the left limit of where we're trying to find our vertex, our minimum point, is. So we want to make sure that we go to the left of our curve. Even if the parabola curved upward, you'd start with that left bound to the left of the curve. And then you're going to hit your enter button. And notice it changes now to the right bound. So you need to make sure that you move that cursor so it's to the right of the curve. Once again, hit enter. Now the TI-83 Plus is designed so that the next thing it will give you is a guess. Okay, so your guess, you can just stay right there the way it is, and you hit enter one more time. And what it will do is it will give you an answer. Now sometimes it's off by way down here in the decimals. So it appears here that our minimum point is 3, -4. And we're going to go ahead and record that, and then I'll show you momentarily how we check to make sure that that's actually right. So our minimum point is 3, -4. That on our graph is our vertex. So we'll go ahead and record that. Now if we want to check that value just to make sure that 3, -4 is on the graph, and sometimes the calculator will do some special rounding, so you get those extra little decimals way down the line. So the way that we check that is you can go into Second Calc, and you can calculate a value. Now we suppose that our x value was 3, so if we put in a 3 here and hit enter, it'll tell us if the y value actually does come out to be -4. And it does, and it shows right on the graph where that is. So we have found our minimum value, our vertex, at 3, -4. And what we can do then is we can actually sketch out on some graph paper the way that graph will look, and we can plot that point. Okay, so I'm just going to do that and show you in a second. Alright, so our x and y axes are set up, so we want to plot that point 3, -4. And this will be our vertex point. Now, what we need to do is also find the axis of symmetry. We don't need to use the calculator again at all for that, because the axis of symmetry is the line where x equals the x value in the vertex. So all we need to do is write in x equals 3, and we can just sketch in our axis of symmetry. Remember, it's an imaginary line where if you folded that parabola, you would see the same image on both sides. That's what symmetry means. So we're just going to sketch in a dashed line at x equals 3 to be our axis of symmetry. Alright, now the next thing that we want to calculate is our roots. Now our roots are our zeros. Those are the points where it intersects the x-axis. So we'll bring our calculator back. And this process is actually very similar to calculating the vertex or the minimum point. Once again, we need to use the calculate feature. So we go into Second Calc, and in this case we're not going to calculate the minimum or the maximum, we're going to calculate the zeros. Now there's 2 zeros, so we're going to have to run through this process twice. 2 places where it crosses the x-axis. So we're going to go down, we're going to choose option 2 to calculate one of the zeros. Now once again, we've got the blinking cursor and it's asking for our left bound. Well, we want to find one of the zeros first. I usually like to work from left to right, so I want to find this 0 first. So what we're going to do is we're going to move this cursor to the left of that 0. Okay, to the left of the place where it crosses this x-axis, and we will hit enter. It then asks for the right bound. So what we need to do is move it to the right of that point. Now you've got to be careful. You move it to the right of that point, but don't move it all the way over here. If you do that, it'll confuse it and it's going to give you an error because there will be 2 roots in that zone, and it only shows you 1 root at a time. So we move it down there and hit enter again for the right bound. Once again, your calculator makes a guess, so we hit enter. And so one of our zeros, or one of our roots, is 1. The x-coordinate is 1. The y-coordinate is 0. So one of our roots is actually 1. So we record that, and we're going to graph our point 1, 0 right here. So there's one of our roots. So when we draw our parabola in, it's going to go right through that. Now we need to calculate the other root. So what we can do, once again, on your calculator, push second calc, and we need to choose 0 again. We're calculating a 0 or a root. Now we need a left bound, but once again we have to be careful. We have to put the cursor to the left of our second root, but make sure it's not to the left of the first root, or once again it'll confuse the calculator and it'll give you an error. So we need to hit enter for our left bound, then move the cursor to the right using the arrow keys so that it goes above the x-axis, past the root to the right bound. Hit enter once again. It will make a guess. We hit enter once again, and then it gives us our value. And as you can see, the value is 5, 0, so our second root is 5. So the roots here are 1 and 5. That's not an ordered pair because the second root is the ordered pair 1, 2, 3, 4, 5, 0. So there we have our first root, we have our second root. Now the last thing that is usually a pretty key point in a parabola is the y-intercept. The y-intercept is actually the easiest to calculate. The y-intercept, remember, is the value when x equals 0. Okay, the y-intercept is the value when x equals 0, so where it is along the y-axis. So that is the easiest thing to calculate. A lot of people will be able to just recognize it's the constant term, but just in case you don't see that, we're going to do second calc, and we're going to calculate a value. And the value we're going to calculate is when x equals 0. We're going to hit enter, and just very quickly it gives you the y-intercept, which in this case turns out to be 5. So our y-intercept is 5. 1, 2, 3, 4, 5. Y-intercept is 5. And then on our graph here, all that remains is for us to sketch in the parabola to match the parabola that's on your calculator. Alright, so there is our parabola sketched out manually. Notice that it does have its vertex point, 3, negative 4. It does have its 2 roots. It has its axis of symmetry, which is x equals 3. And it has its y-intercept, which is 5. You can also record the y-intercept as just 5, or you can record it as the ordered pair 0, 5. Alright, so we have 2 roots, a y-intercept, axis of symmetry, and a vertex. Now some of them don't have 2 roots. If the vertex is right on the axis, then you'll come out with just 1 root, and it'll be just the place of intersection. If the parabola comes out above the axis or below the axis and never actually comes in contact with the x-axis, then we would have no roots. And so there's a couple of other options. Alright, the next one we're going to look at is a little bit more complicated. The windows will need to be adjusted, but any of these parabolas can be graphed. At least the key points can be put on, even if you're doing just a very, very rough graph. So let's get ready for that one. Let's try it with a little bit more difficult of a parabola to graph. Some parabolas, when you first initially try to graph them, you find out that they don't quite fit onto your window. So this one, when you enter it, 4x squared minus 7x minus 19. Looks like that on your calculator. We have done that before, so you know how to do that. And our first step before was to hit zoom 6. That's always our fail safe. Problem is that the bottom of the parabola goes way off the screen. So what we can do with this is you can try the zoom fit option. The zoom fit option should put your parabola completely on the screen, or at least close enough that you can do a minor adjustment in the window. So let's try zoom, and in this case we're going to move ourselves all the way down to 0. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and that's the zoom fit option. And when you hit that, what we notice is it regraphs, it changes the scale so that you can see the entire parabola. Now, you may not like that it's so close to the bottom. It does make it a little bit harder to do some of the calculations. So you are then perfectly encouraged to go into your window button. It shows the window that made it fit. But let's say I want to see a little bit more of this bottom part, but I don't really want to see quite so much of the top part. I can go down and adjust this. Now, my minimum has to be below negative 22.06. So let's take that and maybe adjust that to be negative 25. And then 451, we had an awful lot of extra parabola up on the top, so let's cut this down to maybe 250. And then we're going to hit the graph button and see what happens with that. Okay, that brought that up a little bit. It gives us a little bit more room to see where the two roots are on here. We still have an awful lot extra at the top, so if you want to play with your window just a little bit to make it so that everything fits better, feel free to do that. It's a good strategy. So we need to go back, we need to calculate our vertex, we need to calculate our axis of symmetry, our roots, and our y-intercept. So once again, it's the same exact process. In order to calculate the vertex, you'd go into second, calc, go down to minimum in this case because it was a loop down. We'll hit enter. We need to do a left bound, make sure that you're to the left of the loop and hit enter. We need to find the right bound, so use your cursor until you make sure that you're to the right, hit enter once again, and there is our minimum point or vertex point. Now what you'll notice is that your minimum point in this case is not whole numbers, your vertex. That's okay. You can go ahead and round to the, we'll say the hundredths place so that we just have a place value. So this ordered pair is really 0.87 or 0.88. It's 0.88 and the y value is negative 22.06. So let's do this. 0.88 and negative 22.06. Alright, so we have a vertex point, even though it's not pretty. We still have our vertex point, 0.88 and negative 22.06. Alright, our axis of symmetry, remember, very easy to calculate. All you have to do is say x equals this x value. And yes, you have to put the x equals. Remember, this isn't just a number, this is actually a complete line. Okay. Our roots, the places where it crosses the x-axis. Same process that we used before. You're going to do a second calc. You're going to calculate the zeros, that's the other word for roots. We may need to make our left bound. Make sure it is to the left of and above this root. Hit enter. Move it down just below the axis so it hasn't come all the way over here. So it's down below the axis. Hit enter again. It makes a guess. Hit enter again. And we find out that one of our roots is negative 1.47, or at least by rounding. negative 1.47. Then we need to calculate our second root, same way that we did before. Second calc, going down here to root, or the 0. Use your cursor so that you are to the left of the second root, but you're not to the left of the first root. Left bound, enter. Go up here to right bound, enter. Guess, enter. And then it gives you your answer. The second 0 is 3.22. So we'll put that down as 3.22. There's our second. And then finally, our Y-intercept. It's kind of hiding down there in the bottom. If you want to see a clearer graph again, although you don't even really need to see it. We know it's on there, but let's just push graph again so that you can see it without all that extra stuff. Y-intercept is there. So in order to calculate that, the most easy one, you just do second calc, and we do the value when x is 0, and it's negative 19, and that one is actually, you don't even have to do that. Your constant term will always be your y-intercept, negative 19. Alright, now if you needed to do a paper graph of that, usually something like this you would do a rougher graph of. So we would draw our x and y intercepts, so our x-intercepts are the roots, which is negative 1.47. You'll just approximate this. We'll just write it in. And 3.22. Once again, we'll use a little poetic license here. Y-intercept will be negative 19. We're just going to call that right here, this point. Negative 19. Our vertex is at 0.88, which would be somewhere out here, and down at negative 22, a little bit lower. So here's our 0.88. And our negative 22.06. Remember, the axis of symmetry is the imaginary line that goes up through the middle. And then the only thing left to do is actually sketch the parabola, which goes along like this. Now, it is not drawn to scale. However, the important parts, the parts that you're going to be needing to label and find, are listed on this graph. Your vertex, your axis of symmetry, your roots, and your y-intercept. And that's how you graph a parabola on the TI-83 Plus graphing calculator.